Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at some linear equations that require you to simplify one or both sides of the equation before solving. So in terms of simplifying, there's really a few things that we're talking about, including if there's any factors to distribute, you can do those. Also combining like terms. When you have two variable terms or two constant terms on the same side of the equation, you can combine them together. And we'll also talk about clearing the equation of fractions. And so we'll take a look at all of those in this video. In the first problem, solve 3x minus 5 plus 4x equals 9 times the quantity x plus 2. We've got some like terms on the left-hand side that we can combine. We also have some distributing that we can do on the right-hand side. I'm going to begin with the distributing by multiplying 9 by each term inside the parentheses. So that, leaving the left side alone, 3x minus 5 plus 4x equals, multiply 9 times x, that's 9x, and multiply 9 times 2, that's 18. So I write plus 18. Now on the right-hand side, there's nothing else to do. 9x is a variable term, 18 is a constant term, and they cannot be combined. But on the left-hand side, I've got a 3x and a 4x, two variable terms that can be combined. 3x plus 4x is 7x. Now notice I didn't write minus 3x under both of those because they're on the same side. I can just combine them the way they are. Once those are combined, I have 7x minus 5 equals 9x plus 18. And this looks like one that we've seen in our past. We have variables on both sides, so let's collect them together on the right-hand side. And that can be done by subtracting 7x from both sides. 7x minus 7x is 0. So that leaves me with just negative 5 on the left-hand side. On the right-hand side, 9x minus 7x is 2x. That leaves me with 2x plus 18. Now some students try to move the constant term to the other side at the same time, but I think taking it slow and doing variables first and then constants second will keep you out of trouble. It'll make sure that you get the constants to the other side of the equation. Here I need to move that 18, so I'll subtract 18 from both sides, and that gets me to negative 23 equals 2x, which I can then finish by dividing both sides by 2. Now 2 does not divide evenly into 23, so I'm going to leave it like that. X equals the improper fraction negative 23 halves, which I can then write inside my solution set. Now if you look at the bottom of the screen, problem 8 involves some distributing on the left-hand side this time, and I've got two distributive multiplications to perform. I'm going to distribute 5 into the two terms in the first set of parentheses, 5 times 4x minus 3, and then I'm going to distribute negative 2 into the second set of parentheses, 3x plus 11. The 4x plus 15, there's nothing I can do. I'm just going to leave that alone and wait 1 or 2 steps before I deal with that. So distribute the 5. 5 times 4x is 20x. 5 times negative 3 is negative 15, so I write minus 15. And now I need to distribute the negative 2. And when you're distributing a negative number through two or more terms, remember that that's basically going to change the sign of each term inside the parentheses. So negative 2 times positive 3x is negative 6x. And negative 2 times positive 11, that's minus 22. We still have 4x plus 15 on the right-hand side. And now I've got a couple of like terms I can combine on the left. I've got 20x and negative 6x. 20x minus 6x is 14x. I also have negative 15 and negative 22. Negative 15 minus 22, that is negative 37. Combining two negative terms, add the numbers, keep the sign. You can also do that on your calculator. On the right-hand side, I still have 4x plus 15. Now I've got it down to that same format I had in the last problem. It's basically of this form. ax plus b equals cx plus d. one variable term on both sides, one constant term on both sides. I need to get all the variable terms to one side first, and I can do that by subtracting 4x from both sides. 4x minus 4x is 0. That leaves me with just 15 on the right-hand side. On the left-hand side, 14x minus 4x is 10x. So I have 10x minus 37 equals 15. Now, to get the constant term to the right-hand side, I can add 37 to both sides. That leaves me with 10x is equal to 52. And I finish by dividing both sides by 10. Again, here I've got a case where 10 does not divide into 52 evenly, but they both share a common factor of 2. So I want to divide that from both the numerator and the denominator. 52 divided by 2 is 26. 10 divided by 2 is 5. And there's my solution, 26 fifths. The last two examples in this video deal with equations that contain either constants or coefficients that are fractions. And we'll talk about how to clear the equation of the fractions first and then solve the resulting equation. The problem that's listed is number 9. I have 2/3 x minus 3/4 equals 5x plus 7/2. And I could solve it just like the last couple, get all the variable terms to one side by maybe subtracting 2/3 x, but then I've got to deal with some fraction arithmetic, which I'd rather avoid if I could. Also, getting the constant terms together means I'm going to have to combine 3/4 and 7/2, more fraction arithmetic. I'm going to get rid of the fractions at the beginning of the problem. And I can do that by multiplying both sides of the equation by the least common multiple, or LCM, of all the denominators. So the LCM for 3, 4, and 2 is the smallest number that 3, 4, and 2 all divide into, and that is 12. Notice I ignored the 5. The 5's not a denominator. I only worried about 3, 4, and 2. I'm going to multiply both sides of the equation by 12, and when I do that, I can distribute 12 to each term. Now I'm going to do this in 2 steps, but you could really do this in 1 step, and I'll talk about that. So I'm going to multiply 12 by the 2 terms on the left and 12 times the 2 terms on the right. I distribute that through, and I get 12 times 2/3 x minus 12 times 3/4 equals 12 times 5x plus 12 times 7/2. So basically, I could have written the 12 next to each term in the first equation. To simplify 12 times 2/3, there's a couple of ways you can do this. In your calculator, you can multiply 12 times 2 and then divide that answer by 3, which is going to be 8. Or I noticed that 3 divides into 12 4 times. I could divide 3 out of 12 and 3. And I'm left with 4 times 2x, which is also 8x. Either way is okay. Pick the way that's easier for you. Minus 12 times 3/4. 12 times 3 is 36. 36 divided by 4 is 9. Or I could divide 4 into 12, which goes 3 times, leaving me with 3 times 3, or 9. On the right-hand side, in the first term, nothing to cancel or divide. This is just a simple multiplication problem. 12 times 5x is 60x. And then 12 times 7/2 ends up being plus 42. Again, 12 times 7, and divide that by 2. Or notice that 2 goes into 12 6 times, leaving me 6 times 7. All right, now that all the fractions are gone, and they may come back at the end, but they're gone while we're trying to solve it. I need to collect all the variables on one side. I'm going to subtract 8x from both sides. Again, the reason for that, 60x minus 8x is going to be a positive coefficient for the x term. Then when I divide, I don't have to worry about changing my sign. That leaves me with negative 9 equals 52x plus 42. Subtract 42 from both sides to isolate the variable term. That gets me to negative 51 equals 52x. And I can finish by dividing both sides by 52. 52 doesn't divide into 51. They don't share any common factors. So that is my solution. X equals negative 51 over 52. Notice there I wrote that in the numerator. You can also write it out in front of the fraction. They both mean the same thing. Maybe I'll write it that way in the solution set. They both mean the same thing. Right, one last problem. You can see it at the bottom. I'll scroll it to the top. They both have fractions, and this one's a little different because I've got 1/15 times a set of parentheses with two terms inside. Those are two factors, right? We're multiplying 1/15 by what's in the parentheses. And instead of distributing the LCM to both the 1/15 and the 2x plus 5, because they're factors, I don't do that. I'm just going to multiply it by the first one. Same thing holds true on the right-hand side where I have 1/9 times the quantity x plus 2. The LCM of 15 and 9 is the smallest number that 15 and 9 both divide into. By the way, if you're not good at finding least common multiples, or you don't have a strategy for that, one thing that you can do is just keep taking multiples of the larger one. So start with 15. Does 9 go into 15? No. Add 15 to that. 15 plus 15 is 30. Does 9 go into 30? Evenly? No. Add another 15, and I get to 45, and 9 does go into 45 evenly. So 45 is my LCM here, and I can multiply 45 by the left side and the right side of this equation. 45 times 1/15 is 3, because 15 goes into 45 3 times. And that leaves me with 3 times 2x plus 5, no fractions on the left-hand side. On the right-hand side, 45 times 1/9 is 5, because 9 goes into 45 5 times. Fractions gone. That leaves me with 5 times the quantity x plus 2. Now I can go ahead and distribute on both sides, collect all the variables, etc. Distribute the 3. 3 times 2x is 6x, plus 3 times 5 is 15, equals, distribute the 5. 5 times x is 5x. 5 times 2, that's plus 10. Now I'll get all the variables to the left side by subtracting 5x from both sides. 6x minus 5x is 1x, or simply x. So I've got x plus 15 equals 10. Finish by subtracting 15 from both sides to get the constant terms to the other side. 10 minus 15 is negative 5, and that is my solution. So we've learned a few tricks here when we're dealing with equations where you can simplify one or both sides first, and that includes using the distributive property to multiply a factor into a set of parentheses that has 2 or more terms in it. We talked about combining like terms that are on the same side of the equation, and finally we came up with a strategy for clearing the equation of fractions. In the next video, we'll talk about what happens when we have an equation that doesn't have a solution or has more than one solution, and we'll talk about that in the next one.